One day in lab, you pluck a human hair and shine a laser upon it. The result is a diffraction pattern on the far wall. The figure below shows the apparatus. A. The hair acts to block the laser light. Which of the following situations produces the same diffraction pattern as the hair? One of the most interesting principles of diffraction is that any pattern of openings produces the same diffraction as the same pattern of blockages. Therefore, since the hair is a slit-like blockage, a single slit opening will produce the same diffraction pattern. Knowing this will aid us in solving the rest of the problem. In part B, we are to draw the rest of the diffraction pattern across the scale as shown, and we know for single slit diffraction patterns and now also for single block diffraction patterns, we need to account for the fact that the subsequent bumps are each half as wide as the original, and each one is smaller in height than the central bump. Just like for the single slit pattern, we label the dark points in this diffraction pattern. The first one is A sine theta is lambda. The second is A sine theta is 2 lambda, and so on in both the plus and minus directions. The diameter of the hair acts in the same way as the width of the slit, and therefore we need to solve for the value of lowercase a. We can select any particular feature. I'm going to select the first minimum, and as the starting point we recognize that for all features on this graph, the tangent of theta is y over d. With a y of 2 centimeters and a d of 200 centimeters, we're able to solve for the angle theta to this first feature, yielding 0.5729 degrees. We then use the equation that describes this feature, a sine theta equals lambda, and recognize that the only unknown here is a, yielding a result of 63 microns. In part D, we're asked whether this is a reasonable value for a human hair, and since we know that human hairs range from roughly 50 to 100 microns in diameter, we conclude that the value of 63 microns is in fact quite reasonable.